Here we're going to do page 5 and 6 of the problems for differentiation. Here at the top, it has an explanation about how you use the calculator to find a derivative. And when you find the derivative of a function on the calculator, you are finding the derivative at a specific point. So you are finding the slope of that function at a specific point. The calculator cannot do the symbolic derivatives like you've been doing the last couple days, but that is the other way to do it, and I'm going to show you how to do both. Okay, so the way you do the calculator derivative, it's kind of like when you are analyzing a graph like we've done before. We found zeros, we found minimum, maximum, we found intersections. Well, dy dx, which is the derivative, is in that same list of possibilities. So the way you do it is you do second calc after you put the function in there. So you put the function in the calculator using y equals, of course, and then once you put the function in, then you can use the second calc menu to do dy dx on a certain point of the function to find the graph at that function. So can you use the calculator to do the problems from the last couple days? No, you can't, because the problems from the last couple days, we were finding functions that were the derivative of other functions. But if you want to find the gradient at a specific point, then you can. So that maybe you didn't understand that, but I think you will after you do a few problems. Okay? So let's go down and take a few examples here. So let's do the odds here. We're going to do 1 and 3. So it says these questions can be answered using algebraic method or using the GDC. Make sure you can do both. So we'll start by doing the algebraic method, which you already know how to do. So you have y equals x squared minus 3x, and we are going to find the derivative. So we write usually like y prime or dy dx. Let's write dy dx because that's what they're using here. Dy dx equals, and then so the derivative of x squared is 2x, the derivative of negative 3x or minus 3x is minus 3. So there's your derivative function. And then it says, what is dy dx when x equals 4? Well, when x equals 4, all we need to do is substitute x or 4 into x, and that gives us 2 times 4 minus 3, which is equal to 8 minus 3, which is equal to 5. So we already know that dy dx is 5 at x equals 4. Now, the calculator can do this also. So let's show how we do that on the calculator. I'm going to clear out the things on my calculator here. And then I'm going to put the function in here. I'm going to put 2x minus, I'm going to put x squared minus 3x. Be careful that you put in the original function and not the derivative function. The whole point of the calculator is for it to find the derivative. 2x, or x squared minus 3x, right? Okay, there it is. It's in the calculator. We graph it. Shouldn't be any surprise that it's a parabola. Maybe we can do a maybe a zoom standard. Oh, it was like a window option, wasn't it? That was. Was it zoom? Oh, there it is, zoom standard. Sorry. Okay. And then we want to know what dy dx is at x equals 4. So the way we do that is we do second calc, remember, second calc, and then we go to dy dx. We just push 6, it's option 6. And then we use the cursor to go to x equals 4. Now, we know it's hard to go exactly to x equals 4 with the cursor, so what we do is we just hit 4, enter, and that will give us x equals 4, and then that tells us the dy dx at x equals 4 is 5. So what do you know? We were right, right? Okay. Number 3. If we were going to do it analytically or with, math theory, we would do it like this. we would find the derivative, dy dx equals 11, the derivative is 0. Negative 2x to the fourth would be negative 4x cubed. The derivative of minus 3x cubed is 3x squared. So that is equal to negative 8x cubed minus 9x squared. Okay, and then they say when x equals negative 3, so we just substitute negative 3 in there. We have negative 8 to the negative 3 cubed minus 9, negative 3 squared. So negative 3 cubed is negative 27 times negative 8 and minus 9. Okay, that's like, okay, this is going to be minus 9 times 9. This is going to be 27 times 8. Yeah, I'm going to need a calculator to do that. So 8 times 27 is 216 minus 81. That gives me 135. Okay. And remember, the other way you do it is you put it in the function in the calculator. So I'm going to put the function 11 minus, 11 minus 2x to the fourth. 2x to the fourth. And then we advance with the arrow. And then we put minus 3x cubed. Okay, so now the function is in the calculator. We do graph. I did a zoom fit here, so that's why it fits so nicely. Zoom fit is in zoom option 0. And then I'm going to do second calc to find the derivative. I'm going to press 6. And then I am going to say I want to know at negative 3. And then it gives me 135.00002. You can ignore this 0.0002. You could just consider the 135, and you can see that we got the same answer. Now, the reason why it comes out with this little error at the bottom is because when the calculator does a derivative, it does it the way a computer might do it, which is not the way you do it. You do it using theory and an analytical method, and it comes out exactly right. When a calculator does derivative, it is using a program which does a bunch of calculations, and it does an approximation. Okay, so the advantage is the calculator can do derivatives of very complex functions, maybe even functions that we cannot do derivatives for. Okay, all right, so let's do the odds here, 5 and 7. Find the gradient of the curve at y equals x cubed minus 5x at the point where x equals 6. Now, I'll do some of these analytically. I'll do some of these with the calculator. Okay, so gradient of the curve at y equals x cubed minus 5x at the point x equals 6. Now, notice the way they said this. They did not ever say differentiate. They didn't say take the derivative. But you know what they mean. When they say they want to know the gradient of the curve, one of the ways to do it, besides using the calculator, is to take the derivative, which I just did there. And then, since they want to know at x equals 6, the value at x equals 6 would be 3, 6 squared minus 5, which is 36 times 3, which is 108, minus 5. It's 103. So the answer would be 103. Now look at 7. 7 is maybe one that we could do with the calculator. So let's do the 7 with the calculator. We'll do y equals, and then we clear out the old function, and we put in the new function, which is going to be, and remember, to do this analytically, you would have to multiply it out first because we don't know how to do products. But the calculator doesn't care. The calculator can take the derivative of any function. So we're going to put exactly what's written there. We don't have to multiply it out because the calculator can do everything. Oops, that was an x squared. Advance right parentheses. Okay, so we have the function in there. We can graph it, and so if we it says it wants to know the gradient at the point 1 comma 9. To find the point 1 comma 9, you would just do trace and then hit 1, and that'll give you the point 1 comma 9. We want to know what the gradient is at that point, so we'll do second calc, and then we'll go to option 6, which is the derivative. And it tells us already that the answer is negative 19.7. Okay, so that is dy dx at x equals 1. Okay, so now we'll do 9. We'll do this one analytically. So ds dt is equal to 40, because the derivative of 40t is 40. The derivative of 5t squared is 10t. And so now we're just going to substitute in t equals 0 here, and we're just going to get ds dt equals 40. Okay, so the answer to that one was 40. Now we're going to do 11. This also looks pretty easy to do analytically. So dv dt is equal to 80. The derivative of 7 is just 0. So what about when t is equal to negative 4? Well, you notice that the derivative of this function is always 80. So it doesn't matter if it's t equals negative 4 or t equals 0 or whatever. It's always 80. So the answer is 80. 13. 14h cubed. So we'll take the derivative of dA dH, and we'll get 14 times 3 times h squared. And then what about when h equals 2/3? Okay, so that would be 14 times 3 times 4, because 2 squared is 4, and 3 squared is 9. So actually this cancels out, we get 3 here. So 14 times 4 divided by 3, which is 14 times 4 divided by 3 is 18.666 or 18.7. Okay, that's 13. 15. The derivative of this v function is going to be 4 times 2 times r plus the derivative of 18 times r to the negative 1 is 18 times negative 1 r to the negative 2. So that's the derivative. And then r equals 3 means it's going to be 8 times r, it's 24, negative 18 divided by r squared. So that's actually equal to 2. So it's actually equal to 22. Okay. Now we'll do 17. Why don't we try this one on a calculator, just so that you can get a little bit more experience with the calculator. So we'll do 7r cubed. And in this case, even though it's r, the calculator can't do r. It only does x, so that's okay. We'll just put x. 7r cubed minus 8 divided by r, or x actually. And then we're going to graph it. And then we just need to see what the value of the derivative is at r equals 2. So we do second calc, derivative, and we type in 2, enter. So dy dx is 86. So 17 dv over dr equals 86. Okay, and we'll do the last one also using the calculator. So we'll do y equals, clear it out. We'll put 6r, actually it looks like x there, right? Plus 15 divided by 2x. And we'll graph it. And then we'll find the derivative at r equals. And I needed to do a zoom fit on that. And then to find the derivative, we do second calc, dy dx. And I want to know at r equals 5, so I do 5, enter. And it tells me that dy dx is 13.5. Okay? So that's how you do it with the calculator, and that is the end of page, what did you say? It's page 5 and 6, I guess. Okay?